Good evening, everyone. We welcome you all to Ortho TV online. This is a special webinar. It's brought to you in association with Peekmed company from Portugal. Today we have with us Dr. Levi Reina Fernandes, all the way from Portugal. He is going to be, his main specialty is deformity correction, and he's going to be talking to us on how he uses the Peekmed software and he's going to demonstrate us on doing automatic osteotomy around the knee. On the panelist, we also have with us Dr. Mangal Parihar and Dr. Vaibhav Bagaria from Mumbai, India. So over to Dr. Levi Reina Fernandes.
Okay, thank you so much for the introduction. I'm a dedicated knee surgeon with a special interest in osteotomy around the knee. And together with Peekmed, we developed an automatic osteotomy tool that brought us here today. So just a little bit topic from Peekmed. It's a medtech company based in Portugal, founded in 2015 with a multidisciplinary team, and it's been used by more than 2,000 orthopedic surgeons. So this is a program that allows you to do some trauma surgery planning, osteotomy around the knee, which we will explore later on, templating for TKR and THR, and has cloud integration and PACS integration. So it has a lot of automated procedures already, measurements of angles, and the tool that I'm going to explain now is the automatic osteotomy around the knee. So this is a very important follow-up to this fantastic webinar with my dear friend and mentor, Professor Dr. Christian Clay, that together with Professor Adrian Wilson gave a very good webinar about osteotomy around the knee and how to get it right. And all the principles that I've spoken of are already incorporated in this tool. So I want to start with a basic but important concept that not all the varus are on the tibia and not all the valgus are on the femur. There's an osteotomy in the United Kingdom knee osteotomy registry shows us that around the 500 HTOs that are registered, 80% are for varus and 20% are for valgus. Of the DFOs, 80% are for varus and 92% are for valgus. There's no true epidemiological study on the deformities. So in my personal experience, when I was in Hanover in Germany a few years ago, I witnessed around 30 osteotomies around the knee in 2 months. And I saw that most of them are for varus are on the tibia, but there are some also on the femur and double level osteotomies. And for valgus, you can see that was an even distribution. So I went back to my hospital and did the same study, 53 patients that I managed to collect the data. And you can see on the table that the tibia, varus tibia was only 50%, 55%. On the femur were 15%, and there were double level osteotomies in 30% of the cases. So you see that it's really important to plan and do the proper deformity analysis. So what are the problems with planning? Sometimes there's no deformity analysis or no planning. Sometimes you do plan, but you just don't do it right. But most of the times what I think most people experience is just difficulty in planning. So especially if you are playing manually, especially if you are facing double level osteotomies or joint line congruency angles way out of the normal. So the solution was an automatic osteotomy planning tool that allows the correction on the frontal plane, both single and double level osteotomy, that takes into account the joint line congruency angle, that it's easy, it's fast, and has our full technical support. So the steps, first you start with the deformity analysis, then you choose to take into account the joint line congruency angle, then you select the degree of correction, then you mark the cut, and then you do the automatic cut and measurements. So for the deformity analysis, we look at the mechanical tibial femoral angle that will show us if it's a varus or a valgus, to the mechanical lateral distal femoral angle to show us if the deformity is on the femur, to the mechanical medial proximal tibial angle to show us if the deformity is on the tibia, and to the joint line congruency angle to understand how much of the deformity is coming from the joint. So, of course, if you have the program will tell you, looking at the values that we get, if the deformity is, in cases of the varus, is on the femur or the tibia, same for valgus, or in case you have a double level deformity, it will also tell you that this is a double level deformity and we should be aiming for a double level osteotomy. So taking into account the joint line congruency angle, it's very important because it represents the laxity of the soft tissues. but also, and most importantly, the cartilage wear. If we don't take this into account, we might end up overcorrecting the deformity, because some of the varus might come from cartilage wear or valgus, and it's very important to take that into account. So ideally, to do that, we should have comparative stress X-rays comparing sites, but the problem is that sometimes the other side is not healthy, and these stress X-rays are not always available. So we took this formula that it's on the right screen. We adapted it, and we took into account the mathematical formula that Dr. Christian Clay also has spoken of, and we incorporated that into the automatic osteotomy tool. So the next step is to select the degree of correction. We know that with a neutral axis, there are already more forces going through the lateral compartment, and some surgeons defend that the degree of correction should be adapted to the indication. So if you have a SONG or an osteoarthritis grade 2 or 1, maybe you don't need to go over 55%, for example. And if you have an osteoarthritis grade 3 or 4, maybe we can go up to 60 or 62%. It seems there are some papers showing that there is no benefit with larger corrections. So what we give here is we give you the decision where do you want the new joint line, weight-bearing line to go through, okay? So in selecting the cut, we aim to correct the tibia on the medial side. So either if it's a valgus or a varus, we do it medially, because you don't need to do a fibular osteotomy, no risk of fibular nerve damage, no risk of controllable, you have a controllable slope. It's a safer procedure, and it's also faster. And on the femur side, we advocate for a closed wedge osteotomy, either on the medial side or the lateral side, because you know that the femur is not such a forgiving bone. If you are doing an open wedge DFO, when you end up with an hinge fracture, like on this picture on the right side, you might be in trouble. It's very hard to control the rotation and the opening as well. So we might end up in trouble. And a closed wedge is more stable, has faster healing, and the leg length discrepancy might not be so significant to consider it a disadvantage. So then after that, you just do the cuts and you have the osteotomy. So now I'm gonna try to do a live planning here. So this is the JPEG image, but you can use Dicon as well. So you click and start planning. We choose the knee. Then you need to calibrate. If you have a small sphere here, you can calibrate it automatically, but if not, you just have to do it manually, okay? We go here, 10 millimeters, 10 centimeters. So now here is the image is scanned. Now you do need to go to the procedures. And this patient, actually, I apologize, this patient is wearing pants, but there's a story behind it. We got a new long leg x-ray on our hospital. I was feeling a little sore on my left knee, so I went there to check it out, and this ends up to be my own x-ray. So we're going to plan my future left knee osteotomy. So you click on the left side, knee osteotomy, we start the planning. Now, we do these markings here. You have a magnifier here if you want to help you with the planning, with the marking. If you have any doubts, there's a question mark here that tells you what we want you to mark. Then we go to the distal femur. Tibial width. And then we go to the ankle. And we are done. Okay, so this is the result. You see I have almost 6 degrees of varus. My weight-bearing line is going through 22% of the tibial plateau, and it's clearly because of my tibia, which is in varus. So we go to this wheel here. Here we have summarized the values of our deformity, 6 degrees, almost 6 degrees. The femur is normal, the tibia is varus, and the joint line is okay. So the program tells you it's a tibial varus deformity, so we propose an HTO. So that's what we are going to do. We just mark the HTO here. And now you have this screen where you can take into consideration the joint line congruency angle, and you can choose where you want the new weight-bearing line to go through. If you look on the right, it's moving, and you can choose where you want the new Mikulicz line. So maybe let's go to 50% so I don't get a very valgus knee. So you just do auto osteotomy and the osteotomy is done. It tells you here it's 7.7 millimeters opening. You see the tibia is back to normal, femur it's the same, the weight bearing line is going to 50% and the mechanical tibial femoral angle is neutral. Okay, you can even add if you want a plate. You can put a Tomofix plate, for example. You put it here, and there you go. You have your osteotomy planned really fast, and the patient will be happy for sure. So now I want to show you a few more cases that the tool does. So this is a patient that I was asked for a colleague to plan. He's a 55-year-old patient, previous medial meniscectomy. He has a varus, as you can see. So my colleague said, okay, see if I can do, if he's a good candidate for an tibial osteotomy. So that was exactly what I was trying to look into. So if you look at this, he has 11 degrees of varus, but both the femur and the tibia are normal. So as you can see, this comes exclusively from cartilage wear. There's no extra-articular deformity. So what I told my colleague is that maybe this is not the right candidate for an osteotomy. Maybe you should aim for a partial or total knee replacement because the values are normal. So maybe we need to recheck this. And that's exactly what he did. And he ended up doing a partial knee replacement. So now I want to show you the importance of the joint line congruency angle. You see, it's a little bit high here. The normal is up to 2. So this case is a case where we have varus deformity as well. So the mechanical tibial femoral axis is almost 9. The femur is normal, almost in the limit of the normal. The MPTA is odd, so 85, and the joint line congruency angle is 3.8. So as you can see, this is a tibial varus deformity. So the right procedure to do should be an HTO, a medial open wedge HTO. Now, once more, you get to choose where you want the weight bearing line to go through. Let's aim for 50%, for example. And now you have this, with a simple click, you take into account the joint line congruency angle. So you do the osteotomy. First, the program does an osteotomy on the joint line. So this is a small opening, so it brings the joint line to normal, almost normal. And then it does the open wedge HTO. And now it gives you the millimeters that you need to open. And as you can see, if you look at it, the tibia is at 92 degrees. So this is at the upper limit of the acceptable, 92 or 93 degrees. It's almost the limit that you can go to when you're doing these osteotomies. So, and now I'm going to show you what happens if you don't take into account the joint line congruency angle. If you just ignore it and do, or if you do it, for example, when you are doing manually, it's difficult to control the joint line. So if you just ignore the joint line congruency angle and you aim for the same 50%, the result is that you end up with an opening of almost 12.5 millimeters. And if you look at the tibia, it's at almost 94 degrees, the tibia. So this is a little bit beyond the acceptable. What happens is that you end up with a big obliquity on the joint line, and the survivorship of the osteotomy might be at risk. So with a simple click, you don't have to worry, you just click it and you take that into account. So I'm going to show you some more complex cases. This is a double level osteotomy because, as you can see, the patient has a varus coming from both the tibia and the femur. So the program tells you it's a varus deformity. We propose a combined HTO and DFO. And if you click next, you just do the markings of the HTO. You do the markings of the closed wedge, lateral, DFO. And then it's the same thing. You just select the degree of correction that you want to do, where you want the new weight bearing line to go through. And then you just click on auto osteotomy and it does the cuts. It says how many millimeters do you have to cut on the tibia, how many millimeters you have to close on the femur. So in this case, if you see, you would take 7 millimeters from the femur, and that same wedge could be used for the 6.4 millimeters on the tibia. So you see a complex deformity, really easy to perform, everything's at green, so you're doing the right thing. Okay, now I will be showing you one more case. This is actually a patient of mine. She's 55 years old. She works in a cafe. She has a cafe. As you can see, it's a huge valgus, a lot of cartilage wear on the lateral side. So you see everything is at red, weight-bearing line. You can't even see where it goes through here because it goes beyond the tibial plateau. So it's the same thing. It tells you it's a 16 degrees valgus, the valgus on the femur and the tibia. And with the, let me just show you here. It has a 6.6 degrees of opening of the joint line congruency angle opening on the medial side. And since it's a valgus deformity, we propose a combined HTO and DFO. So we do the same thing. We mark the cuts as the software tells you on the left screen. And we select the joint line congruency angle so it can correct a little bit of it. It can't correct it all. You have a big cartilage wear on the lateral compartment. So after we do our selections, it tells you, it does the automatic correction. It tells you how many millimeters you have to take from the femur and how many millimeters you have to take from the tibia. So actually, when I did this osteotomy, I didn't take that into account, the joint line congruency angle, because this was previous to these new concepts that we've been studying. So as you can see in the result, the patient has a varus knee, well, it's corrected, but it's a little bit and slight varus. This is because the tibia is a little bit varus, and we end up not being able to put the D-screw. But since this is a closing biplanar closing wedge, it healed very, very good. So she's 6 months here with a good range of motion and very happy. So I want to now get back to when I went to my previous institution, and analyze all the osteotomy patients. When running that through the tool, it shows that the osteotomy tool suggested a different procedure in 50% of cases. So this might be cases where the deformity was on both bones and we only corrected one, or in the case of there were no extra-articular deformities and we did an osteotomy as well. So the key message is it's very important to plan the osteotomy and do the proper deformity analysis. So for future directions for me and Peekmed, we welcome every feedback we can get from everyone that is using the program. We will try to introduce more osteotomies to the automatic planning because we are having some surgeons that still prefer to do lateral closed wedge HTO for varus on the tibia and lateral open wedge DFO for valgus on the femur. And we will continue looking up at the latest evidence to keep this tool the most advanced possible. So I would like to thank you all for your attention, and I'm gladly answer your questions now. Thank you.
Levi or Levi? How do you pronounce your name?
It's the same. You can use it both. It can be Levi.
Okay. So that was a nice demonstration of everything that the software can do. I've got 2 or 3 questions. Number one, when you showed us the scaling,
yes.
Normally what we do is we put a 30 mm sphere in the plane of the bone.
Okay.
But what you did on this was you put it on that calibration, which I think is on the plane. So the magnification on the film plane is less than what you would measure it off a sphere, because the sphere is away from the film. Does that affect the accuracy?
Well, you have to find
you're talking of millimeters.
Yes, this software, that the new machine that we have, it actually has an inbuilt calibration. So, and the ideal would be to have a marker close to the knee, and we have a sphere for that, or a coin. It's not ideal because it's not spherical, but we can use a coin as well, and have it as close to the knee as possible. So, and in that case, you would be aiming for the best correction or the best measurement calibration possible, of course.
Because one of the problems, any machine which calibrates itself, you know, if you've got a thick thigh,
yeah,
and
true.
if you've got a thin thigh, that's going to have a difference. And we are measuring, you know, 6 millimeters, 7 millimeters. So having the leg, the bone that far away from the X-ray plate will give you a magnification, even if you have a machine which is automatically calibrated.
That's something we need to solve. Yeah, it's a problem.
So you've used this in how many cases now?
Well, I've been planning for a lot of colleagues of mine as well. So we've been using for more than 100 cases already.
Okay. So what I wanted then was, when you've planned on the software, you then also double check it with the alignment rod on table, right?
Yeah, but we do that. Actually, there's a study that you can also do it with the string from the electrocautery. But the thing is, I think it's more, our experience, and I've been talking with with a lot of colleagues, is that if you just stick to the plan, it's more accurate than what you do in the alignment with the alignment rod in the OR. Because if you move a little bit the ankle, if you don't do enough pressure in the ankle to simulate weight bearing, if you move a little bit on the hip, it changes everything. So we do it, but what we found is that if we just ignore and you do exactly what you planned, it's actually more accurate than you trying to measure it on the table, because it's really dependent on your assistant as well. If you have the ankle and the knee in the right position, if the patella is facing forward, so it's harder to. I don't think this is something we are discussing as well, because in my opinion now, what I did is I forget the rod, and that's just do what I planned.
Right. So that's very interesting, because that leads to a follow-up question. You've done 100 cases. Have you looked at the post-operative, the measurements with the same software, you know, that you planned for 55, say 50%?
Yes, that study is on
How much
track.
did you get?
That study is on track. But the thing is, even if you plan it very well, it's always depending on the surgical technique. So what we see is that the patients that we aim for 50%, for example, you are doing it. If you're doing the last ones that we did, as I told you, where we forget the rod, we are actually getting good results, 1%, 2%, 3% of difference. So there are some that I plan for colleagues of mine, and I don't have the feedback of the full result. But if you ignore it, and the range that we get, it's really close to what we plan. And this is a good thing, because this shows us that when the joint line congruency angle that we are taking into account is working. So there are a lot of big deformities as well. And if we are, the joint line congruency angle correction is not something totally explained yet, but we are using this formula, and it's working, because the doing as we plan, we are not getting too far away. We never had more than 5% of deviation, for example. So if you aim for 50, if you end up with 45 or 55, you can still consider that a good result.
But if you have a certain amount of joint line opening up,
yes,
and in that patient, instead of 55, you go to 45, it's quite likely that the joint line may not open up, because there is a point at which, when the weight bearing axis, say let's talk about a varus, only when the weight bearing axis shifts a certain
50%.
amount, only then it will tip over. I'm not so sure that it is always 50%, because sometimes you get it 50%.
It depends on the cartilage wear that you have. I think it depends also on the cartilage wear that you have. You know that as you go, if you have a medial osteoarthritis, as you move to the lateral side, the cartilage wear on the medial side will each time will be a lesser of a contribution to the deformity. So in that case, we try, this is the best we can do to take that into account and shift the minimum amount that you can to control it. So this is something that we are learning too, and as we are doing more and more osteotomies, we are taking that into account. And I have cases where I did, for example, for a valgus osteotomy, for a valgus knee, I did a tibial closing wedge osteotomy. I closed exactly what I planned, but even so, I couldn't shift the load totally to the medial side. So the cartilage wear was a little bit more than I assumed. And when I did the correction, if you miss 1 millimeter, for example, it might be enough to not get it for 50%, for example. So that's something that we are, but if you don't do any analysis of the joint line, then it will be a total disaster for sure.
No, of course. So my question was exactly that especially now that you have the sort of a good tool to measure the joint line, you know, whatever you study out of this will be quite useful in the sense, in how many cases did the joint, what kind of plan?
Sorry, I'm missing you. I can't hear you.
In is what they call the tipping point. And if I understand it right, in a lot of these lateral laxities, that tipping point is somewhere on the lateral tibial spine and not in the center, which means not 50, it's closer to 55, 60, when you have a large amount of lateral opening. That was what my understanding was. Especially if you've got, you know, a tibia vara, not only because of cartilage damage, also because of primary tibia vara, which we have a lot of in
Yes.
India. We have a lot of that kind of deformity. So the lateral, and then you want to ensure that it's close, then you want to go at least, because what you're talking of is, I think, 0 degrees of valgus, mechanical axis perfectly straight when you say 50%.
Yes, but the thing is that the software allows you to do that correction. If you think that the tipping point is around 55%, for example, you can select it. I designed it so you can use your own ideas and do the correction as you want. Of course, there are some advocates of larger corrections. It's okay. We don't have. You just have the possibility to do the correction as you desire.
Right. So
I showed you always 50% in the examples, but of course you can go further.
I understand. So
It is if you have a lot of cases, or if you have
follow-up in terms of.
Sorry.
Yeah, no. I mean, to look at your follow-up study in terms of how well we are, because the point you made that you know, there is certain things which come with your surgical technique also. What I have realized is I have always tended to estimate the correction with other ways of planning. And therefore, I will generally tend to go maybe a couple of millimeters less, and then double check with the rod. So what that basically means is I'm not sure where my mistake is coming in from. It's from surgical technique. But once you say you have your cases, more people are looking at this now, then we get the numbers and we can find out exactly how much we need to factor in the joint line convergence angle. I'm sure you need to factor it in, no question about that. So I think that's a good aspect of the software.
Yeah. Also, it's not something isolated. So if you're planning a correction and you see that the correction that it's giving you, it's turning the bone that you are correct the deformity in, with a large over deformity. So if you get a tibia of 93 or 94, maybe you should check it. Maybe we should check it out and see, okay, maybe this is not the correct procedure, or I'm not doing something right here. Maybe the femur has also a deformity or not. And that's where the program can help with, to not overlook some of the smaller deformities on both bones as well.
Yes, that's true.
With that study that we did, we learned a lot. So 50% of cases where we should do something else, it's a really big number. So we started to carefully plan our surgeries a little bit better, and we hope that will bring better results in the future as well.
Certainly. Great. Vaibhav? My friend Vaibhav is Vaibhav, my friend, is an arthroplasty surgeon.
So, yes, his microphone is muted.
No, I'm on now.
He's on now.
Yes.
Yeah. No, so very impressive software. Yeah, impressed by the entire planning and the concept of JLCAs. Now, as Dr. Mangal said, I'm primarily an arthroplasty surgeon. So my questions would be relatively simple. So could you quantify where the virus is coming from with the help of the software? For example, there is a convergence angle, which kind of give you a surrogate marker that it's the cartilage that is contributing to the deformity. So if you had a software which could tell us that, look, 10% is contributed because of the loss of cartilage, there is 50% coming from the metaphyseal remodeling, and maybe 40% which is extra ligamentous. Is that possible? Because that would change the way we think of the varus as a large subset.
Yes, but that's already what we are doing. We don't know for sure, but we are attributing to some. We look at the formula that is on the osteotomy book, where you can. What we do is, if you have stress X-rays with the patient with a good knee and a bad knee, if you do a stress X-ray and you reduce the deformity, a varus deformity that the patient has, and you compare the difference in the millimeters of opening on the lateral side, for example, in the varus, from one side to the other, those millimeters are the millimeters that come from the cartilage wear. So with that formula that it's on the book, if you take that, there's a constant number. If you take that and you divide it by the tibial plateau, you get the degree of varus that comes from the cartilage wear. I can show you here, I can show you the formula again, and I will tell you exactly what I'm trying to show you.
Yeah, but could you quantify it for each patient? Because normally the varus would be a combination of both of those, meaning a cartilage wear and some amount of metaphyseal remodeling, and possibly also a constitutional varus.
Yes, I think it's possible to get the actual contribution of each one.
Because that would tell me in which patients I would be choosing an osteotomy vis-a-vis in which patients it's primarily a cartilage issue, and that I should be addressing cartilage at the joint level.
Yes, if you think like this, if there's any deformity, extra-articular deformity on the bone, even if it's small, and if there is a large contribution for the cartilage wear, you can still do an osteotomy. If you have a metaphyseal deformity, you can still do it. But you must know that the results will not be so good, because the more arthritic the knee, the worse the results. And you can't overcorrect the metaphyseal bone to a point where you get a huge joint line obliquity. So osteotomy, it's what you could call like a more palliative osteotomy, where you have already a very, very important cartilage wear, but you still have some extra-articular deformity.
Exactly, that's the point. So would software tell us that, look, these are the guys who should be referred to me versus who should be sent to Mangal?
No, you can send all to me, because I'll do joints also, not a problem.
No, actually,
same here. But I do.
One of the points he made initially was that only, that the software calculates your LDFA and your MPTA. Now, if your MPTA and your LDFA are both normal, 87 degrees, then this is primarily a cartilage
arthroplasty
or
system.
a lateral laxity. That also could be there. But now, whether it's lateral laxity, how much lateral laxity and how much cartilage, you will have to decide by doing stress X-rays of both the sides and comparing that. So
No,
what cartilage is not gone is lateral laxity.
No, I understood that part of it. What my point is the question is, what do you define as joint? Is it just the joint line, or is it what is something which is, when we call it an extra articular, it means an extra ligamentous deformity. That means that we must know what's the attachment of SMCL on the femoral side, on the tibial side. Okay. So
Yeah, but
for me, extra articular deformity is one which is more than 7 centimeters away from the joint line on the tibial side, and more than 3 centimeters away.
Oh, you are talking of whether I will be able to correct this deformity by a replacement, or whether it needs an extra articular osteotomy. That way.
So three things. One, whether it's a pure joint issue. Number two, whether it's a metaphyseal issue. And whether three, it's a primarily tibia vara. In which case, and as a surgeon, I might choose to do either of the three things. But would the software give me that information as a quantification? So example, someone would have some contribution coming from the joint line congruence angle to suggest that, okay, there is this degree of cartilage wear, there is this much of the metaphyseal remodeling contributing to the virus, and probably this guy also had an extra articular constitutional virus, which you may have to leave when you are planning your correction, either as a joint or as an osteotomy.
Yeah, not in this particular automatic software, it doesn't do it like that, but you have the deformity analysis, and you can look at it as, you can look at individually at the joint line congruency angle, individually at the both values, but it doesn't give you the right percentage of each one.
Exactly. So that is what I do manually. So when I plan any deformity correction,
but you don't need to do it manually. You can,
yeah, so
just mark the points and.
Yeah, so if your software could tell me that, look, these are the three components, and you can choose what you want to correct, that would be really great, rather than doing it manually for us.
Of course, something we will look into.
Yeah.
You also do this in 3D, or this is only in 2D?
That's another.
No, at the moment, since when you are planning an osteotomy, you're looking at the long leg X-rays mainly. So we make it simple, and we use the long leg X-rays. We do some manually plan. You can do everything this does automatically. You can do it manually. So what I've been doing for some friends as well is and colleagues, I've been doing some another type of deformity corrections. For example, for tibial slope changes, for patients who have 3 ACL ruptures and re-ruptures, and you end up finding that they have a really increased tibial slope. And I've done some manual planning of that. On 3D, we could use them for especially those blunt deformities. It would be important to do a three-dimensional correction as well. But since those cases are so rare, we can't do it automatically. So you can do it manually. You can look at the CT or the MRI manually, and you can make some cuts on them. But automatically, to plan a double blunt deformity in several planes, it's not well,
but
feasible.
manually you do use 3D planning.
Yes, for example, for trauma, you can, if you get a tibial plateau fracture, you can divide the fragments, separate them, see where they fit in a plate, see where you're going, where the plate is, try to measure the size of the screws if it's calibrated. There is room for that, of course. It's not, but it's impossible to do it automatically now. But we don't say we won't be able to do it in the future as well. We don't know.
Right.
We are always evolving.
And the 3D requires a CT or an MRI or either?
Yeah, I think it's both, but Joan can confirm that.
Joan, you want to say something?
Yes. So thank you for the question. And you can use either the CT or the MRI, and the system will automatically generate the 3D model for you. And then you can also ask the system to automatically segment the image for you instead of having to cut all the pieces of bone individually and manually. So the system will do that for you as well. But you need to use a CT or an MRI.
And how sort of easy or accurate is that segmentation, especially in trauma?
So we are actually conducting a study internally to compare with what we call the ground truth. So it's like having a person to manually segment the image slice by slice, and then to have the system to do it automatically, and then compare the two and see if we are losing any information especially on the bone. And so we are conducting the study. So far, the results are quite good. But at the same time, we are also improving those algorithms, not only to make them more accurate, but actually to make them more quicker. So to be able to perform an automatic segmentation in just 8-10 seconds or something like that.
Okay. Great. And what about stuff for arthroplasty and all? You have templates which will go on to 3D there, or how do you manage that? Meaning
Yes.
you mark out the cuts and stuff?
Yes. So like Dr. Levy was saying, it's possible to manually plan any kind of orthopedic procedure using all the tools that we have on the top bar. On top of that, what we are doing, and this knee osteotomy module is quite good to exemplify that, is we are making those procedures more automatic. So we are giving artificial intelligence on top of that in order for the system to perform the harder tasks for you automatically. So for example, for the TKA, that's the same thing. So today it is possible for you to go there and manually plan on 2D or 3D. We are also now finishing just one of the modules for you to be able to plan with an X-ray automatically a TKA. And as soon as we release that, we will do the same thing in 3D. So we are developing all of those modules on top of what we have already currently, which is having either a manual or semi-automated procedure, and then we are adding artificial intelligence on top of that to make it fully automatic. But today you are already able to go to the templates database, see if we have the 2D or the 3D templates. We don't have the whole database in 3D because that relies 100% on what manufacturers provide us. But today what I can tell you is the Stryker database, we have both 2D and 3D. Zimmer's almost the same thing as well. And then for the other brands, we have a couple of implants in 2D and 3D.
Right. Neeraj?
So could, I mean, these planning software, could they export it to create mechanical jigs? Can we export the data to get some meaningful information to print it for 3D jigs for doing osteotomies? Or
I'll let Joan answer this question as well.
Yes. So what you can do, although we don't design the jigs, or you don't have an option to design the jigs automatically on the system. What you can do is you can export, if you are using a CT, for example, and you have performed some form of automatic correction. What you can do is, in the end, to export the STL file from the system. So that you can do. So as soon as the system identifies the bones, you have an option on the file button, and then you have export to STL, and then it will generate all the STL files to the bones that you have selected. And with that, you can use the STL file to then design your own jigs.
So the STL file would actually print the bone, but
yes.
Is there a method to reverse print for a jig? Is there a manual? Is there a software to do it automatically?
Yeah, I don't think there is a software in the market to do that automatically. What you can do is, there's a lot of systems in the market that allows you to use an STL as a base, so an STL of the bone as a base, and then to design some form of custom-made jigs or PSIs on top of that. So there is there are some products in the market that allow you to do that. I don't think you have any automatic system to do that. No. I don't know if I answered your question, but that's
that's right. I mean, I thought that Materialize did something for that could automatically give us, once we have marked out our osteotomy site and planned it well. I mean, you can just reverse engineer a jig based on the negative contour of the bone. I'm not sure. I've not used those.
Yeah, that you can do, but you need to design the kind of the first part of the jig, meaning that if you have the bone and then you have some form of deformity or something that you want to cut, and then you need to have a piece of something that you put on top of the bone, and then you can do some it's basically algebra in the back to do the negative of that you can do, but you still need to have an STL file of the jig or a base of the jig.
Yeah, the base of jig,
like a block or something.
But that would be easy. I mean, once you have one ready, I mean,
sure,
that could
for sure
incorporated.
For sure.
Good.
Very well.
Okay. Yeah. So Dr. Vaibhav, Dr. Mangal Pariyar, he has answered, I think, all of your queries.
That's right.
Yeah. So he, Peekmed, Mr. Ribeiro is generous enough to give us all, not one, but two, but all of us 3 months free to use. So there is a Google form which I had sent to all of you and to all Ortho TV viewers. You can fill it up and you can use this software for the next 3 months. So whenever you, maybe you can fill up the form a little later when the lockdown opens and you're ready to do the deformity again. And your 3 months will start from then. And if you are okay with it, then you can go and buy it and buy the software. But the first 3 months completely free for all Ortho TV viewers. Am I right, Mr. Ribeiro?
Yes, you are fully right. So you will be able to use for 3 months the whole system. So you'll be able to use with 2D X-rays, with 3D CT scans or MRI. So you can use the whole system for 3 months. We will be happy to have you in our group of surgeons worldwide using our system. And if you have any further question on the system or on a specific feature, we'll be happy to answer that.
Okay. So thank you very much. We thank Dr. Levirena Fernandez. We thank Mr. Ribeiro, and we thank our panelists, Dr. Vaibhav and Dr. Mangal Pariyar.
Thank you.
Thank you very much.
Thank you.
Thank you very much for your time and for the opportunity. Thank you.